So it's in descending order, no greatest common factor, no negative leading coefficient, no special product. Negative 15 is not a perfect square, and 1 is not the leading coefficient. So I have no choice but multiply these two numbers and get negative 60, and then the sum never changes. So can I find two numbers whose product is negative 60 and whose sum is negative 4? Obviously, one has to be negative and one has to be positive. And the negative number is bigger, fatter if you want, than the positive number. So what do I get? Good. Careful. Oh, yes, you already said negative 10. Thank you. Perfect. So now what happens next with these two numbers? I cannot use them to factor. I can only use them to replace the middle term because the leading coefficient is not 1. So can anyone dictate the new problem, which is really the same problem, but it will look differently. So it's 4x squared. It doesn't matter the order you write these two in. You can write plus 6x minus 10x, or you can write negative 10x plus 6x. If I find the factored form, you cannot find another factored form. If a polynomial is factorable, there is only one way to factor it. So it doesn't matter. So plus 6x minus 10x minus 15. And then I'm covering the last two so I don't make a mistake. So if you have a binomial that is 4x squared plus 6x, what will you do with it? To factor, how will you factor? Excellent. What is left in parentheses? Very careful. Yes, right? What should I get from the other two before I even look? If I don't, I want to write it first because I may mess it up. Who knows what else I come up with? So I write it first and then I look. I need a sign and a factor in front. What will those be? It will work. I know it will. How do I know it will work? Because I found those two numbers, 6 and negative 10. Once I found those two numbers, if they exist, then the polynomial will be factorable for sure. Indeed. Let's check. Negative 5 times 2x, correct. Negative 5 times 3, correct. So then the final simplified factored form, I should say, sorry, is what? What comes out? Of course, that's the common factor. And what is left? That's it. Okay, so now we come back to b, which is 2x squared plus x plus 1. I go through the strategy. It's in descending order. It's a trinomial, no greatest common factor, no negative leading coefficient, no special product. 2x squared is not a perfect square. 1 is not the leading coefficient, so I'm down to the last chance. This is the last chance. So I'm looking for two numbers whose product is very good. You incorporated the leading coefficient because it wasn't 1. Very good. And then whose sum is 1. Good. The product is positive. Both numbers have to have the same sign. Since the sum is positive, they must be positive. So can I find two numbers, positive numbers, whose product is 2 and whose sum is 1? I can only have 1 times 2 or 2 times 1. But 1 plus 2 is not 1. So what is our conclusion here? Not factorable. Okay, last one here. 5x squared minus 26x plus 5. It's a trinomial. It's in descending order. No greatest common factor, no negative leading coefficient, no special product. Let's take 1 minute and work on this. It's possible that I didn't lose the first video. The product. Careful. Very good. Sum. Since the product is positive, both numbers have to have sign. It's the same sign, but their sum is negative, which means both numbers have to be negative. Can I find two numbers whose product is 25? Two negative numbers whose product is 25 and whose sum is negative 26? That's it. Perfect. So then I go back. Can anyone tell us how to rewrite the problem? Yeah, that's okay. Good. I cover the last two. And I look at the first two. What do I write? I start with two terms. I must have two terms. See, if I finish here, then I will never recover that. Exactly. Indeed. So what has to come out from the other two? Otherwise, I can't continue, and I know the polynomial is factorable because I found the two numbers. Absolutely 5x minus 1. Mandatory, 5x minus 1. Good. These have to be the same, otherwise I will not be able to finish it up. So now, but I cannot, I'm not saying that you have to fabricate it, right? We can't fabricate it. It has to be there, but it is there. So then what do we have in front? Indeed. So what is the factor form? Now I can write the factor form. That's it. Very good. Perfect. Final strategy, last one. Polynomials. Okay. Number 1, the same thing. Number 2, the same thing. Number 3, the same thing. Number 4, the same thing. Same. The question is, what is it? I will say polynomial. If it has 4 terms or more. If it has 2, I know the strategy. If it has 3, I know the strategy. But if it has 4 or more, it's a polynomial. So I'm asking myself, what is it? Then if it's in descending order, then if it has the greatest common factor, and then if it has negative leading coefficient, and this is the easiest possible one, no formulas, no special products, factoring by grouping, and that's it. This whole strategy is found back on the first page, if you'd like to quickly look with me. Check whether one or more of the 4 binomial special products is or are applicable. If not, I didn't put commas here. If not, the binomial is not factorable. Note There are binomials for which the difference of squares and cubes can be applied. Yes, I can show you an example. Trinomials. Check whether one of the two trinomial special products is applicable. If not, check whether the leading coefficient is 1 and apply the appropriate strategy that we talked about. If the leading coefficient is not 1, apply factoring by grouping after you change the trinomial into a polynomial with 4 terms, as we just did. If not, the trinomial is not factorable. So now we reach the polynomial. 4 terms or more. Apply factoring by grouping. There are 3 possible ways to group 4 terms in groups of 2. So if I have 4 terms, I can group the first 2 and the last 2. I can group the first with the third and the second with the fourth. Or I can group the first with the last and the middle 2 together. So if I group 2 and 2 and it doesn't work, I cannot conclude, oh, it's not factorable. No, I have 2 more options. The first grouped with the third and the second with the fourth, or the first and last and the middle 2 together. Okay? So that's what this says. Then the polynomial is not factored. Important note, some 4-term polynomials can be grouped in 1 term and 3 terms, and then a binomial special product is applicable. So I can show you an example of that. But this is the strategy summarized here. Okay, back. So let's go and factor these polynomials. Okay. Here's the first example. And we have 2x squared minus 4x plus 6x cubed minus 24x to the 5th. What type of polynomial is this? It's a polynomial. It's not a binomial. It's not a trinomial. Is it in descending order? The answer is no. What is the degree of this polynomial? Because that's where I have to start. So degree 2, degree 1, degree 3, degree 5. So this whole thing is degree 5. So I have to start with negative 24x to the 5th plus 6x to the 3rd plus 2x and minus 4x. Greatest common factor? Yes. Negative leading coefficient? Yes. So what will I pull out? Negative, definitely. And what is common to these 3 terms, to these 4 terms? 2 indeed, and what else? That's it. How many terms will you write in parentheses? Absolutely mandatory. 4. And they are 12 plus, I'm sorry, minus. Yes, minus. Oh, I messed up something. I'm sorry. This is, I didn't copy this, the power. This is 2 here. Sorry. Good. Minus. Minus x. Just x. And plus. Just 2. Because negative 4x times 2 will give us negative 4x. Then this is it. There is nothing else we can do there. Actually, let's give it a shot. I just looked at it. Okay. So now let's look at the first 2 terms, because the only chance I have is factoring by grouping. So negative 2x stays outside. What will you factor out from these 2? 3x squared indeed. And what is left in parentheses? Good. Okay, now let's look at the other 2. The only thing I can factor out here is negative 1, and I get x minus 2. So since I cannot continue, this step is not required. And I can stop right here. There is nothing I could do continue. I cannot factor out anything. And there is nothing else you can do. You cannot group the first with the third or the second with the fourth. It's not going to work. Even if you try to group these 2, it's not going to work. So this step is not required. And this is good enough. Okay. Now the other examples here. X cubed plus x squared. These are the easiest ones, really, with 4 terms. X cubed plus x squared plus 2x plus 2. What will you factor out from the first 2? What is left in parentheses and how many terms? Yes. What should I have coming out from the other two? Otherwise I can't continue. Do I have it? I can't fabricate it. It has to be there. Is there? If you forget the sign, you're changing the problem completely. So I need a sign and a factor. What is the sign? And the factor? So what is the factor form of this polynomial? The common factor is? Yes? What is left from the first term? What is left from the second term? That's it. If you ever have doubts, how would you check this? Right, here it is. X times x squared, and I get x cubed. Done. X times 2, and I get 2x. Done. 1 times x squared, and I get x squared. Done. And 1 times 2, I get 2. Next problem. X cubed plus 2x squared minus x minus 2. This is not going to be enough, although we finished all the factoring. We didn't get the chance to apply this right now, but I highly recommend do as many problems as you can from section where they have everything put together. Yes, section page 411. 411. It's everything put together, everything. Page 411 and 412. Do the odd number problems that have the answer in the back. So page 411 and 412. All the odd numbers or every other odd. You can say, that's insane. I'm not going to be able to do 80, 90, 100 problems. Okay, do 25 of them. Start with 1, skip 3, do 5, skip 7, do 9, skip 11, 25 problems, and check the answer in the back. Okay, good. So 4 terms, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, of course not. There is none. So my only chance is factoring by grouping. From the first 2, I will factor out. Good. What is left in parentheses? Very good. What should I have from the other 2? Otherwise, I can continue. Good. Now I uncover it, and I have to find a sign and a factor. What do I put in front? Minus 1. What is the common factor now? Yes. What is left in parentheses? But in the binomial strategy, I know that x squared minus 1 can be further factored. How do I factor x squared minus 1? Is it a difference of squares? Is it a difference of cubes? What do I do? How do I factor the difference of squares? From rationalizing and from dividing complex numbers. Okay, see? 2x cubed minus 6x squared plus x minus 3. Descending order, greatest common factor, no. Negative leading coefficient, no. Factoring by grouping. From the first 2, What do I factor out? Excellent. What is left in parentheses? What should I have from the other two? Good. Now I uncover it and I'll look and see. I need a sign and a number, a factor. If I don't write the sign and the factor, I will mess it up. Plus 1. So then the factor form is? That's it. X plus 2y. We don't have to do this one. If you remember, we just did it before on the front page. This problem is the same with this problem because it belongs to both. Binomial, if you expand this, you're going to have 4 terms. So we don't have to do this again. So let's do a squared plus 6a plus 9 minus y squared. So I have to be careful. It's not very common, but here's what I was saying here for the important note on the front page. Some 4-term polynomials can be grouped in 1 term alone and 3 of them together. And this is an example of that. There is nothing I can do. If I group these two, then I will factor out a and I get a plus 6. There is no a plus 6 here. If I group these two, I will never get something common with this. If I group these two, I will not even be able to factor because it's the sum of squares. So what happens here is this is a type of example in which these 3 go together. So forget about this one for a moment. Can anyone give us the factor form? And we had this problem in trinomials a few minutes ago. What was a squared plus 6a plus 9 replaced by? Very good. Now I copy y squared. And now I'm asking you what this is. And I'm going to cover it so it doesn't confuse you. It's the difference of what? Perfect squares. Is the difference of perfect squares factorable? That's the sum. The sum is no. But yes, the difference is. How will I factor it? I'm still covering it because I want you to say it first before we write it. I will have what I have in my right here under 2 fingers, right? Plus what I have under 1. And then this minus what I have under this. So this plus this minus this, correct?
Yeah.
Okay, so now you'll tell me how to write it.
A plus 3 plus 1
Exactly.
times a plus 3 minus 1.
That's it. So it is possible. It's not common though. These examples are not common. But it's possible that I will have to do something to 3 terms and then be still able to factor. But this was not, this was somewhat grouping in the sense that I factored these 3 into this. I grouped these 3 in here because we know that this has 3 terms. And then I factored. And, okay, so I still have 2 minutes if you allow me just to explain this because I would like you to work on these problems if you can, as much as you can. And then I was hoping to finish this today, but it is what it is. So the principle of zero product. If a and b are 2 factors or 2 real numbers, the equation a times b equals 0 is true if and only if. So if I have a times b is 0, what can happen? Exactly, you can fill it in. If a is 0 or if b is 0. So I'll stop with this problem. X minus 2 times 7 minus 4x is 0. So this is our factor a and this is our factor b. So either one can be 0. If factor a is 0, I'll get an x. If factor b is 0, I'll get an x. Now, how do I solve this equation to get an x from here? That's it, and it's done. How do I solve this one to get x? Well, first I have to move 7, right, or subtract 7. And then x equals 7 over 4. We've been doing this the entire semester, but I wanted to review factoring, and I also want to go through different equations to solve using the zero product principle, which requires us to be able to factor. I would not be able to use the zero product principle if I don't know how to factor the equation, the polynomial in the equation. Any questions?